Here they are. When implementing unit tests, it is a good practice not to use the actual file managers or notification centers or other services, but to replace them with some fakes which only mock the behavior of this code. Also, probably in tests, you would like to enrich the behavior of these dependencies, so they could, for example, log off all the external calls, the parameters provided with these calls, or tune the returning values of some methods, and so on. And there are tons of ways in which these mocks could be implemented in your project. And if you would like to implement them all, then, well, for sure you're going to suffer from some inconsistency problems. In my code, personally, I prefer to use a very small set of templates for mock generation, which I'm going to present you today. So let's take a look on the state of this demo project. It contains only one real class, the system under test, which has one single dependency named dependency. And there is a set of methods on this class. Executing any of them will cause some execution of some stuff on the dependency. And the dependency has all kind of APIs. There are methods without parameters, there are methods with multiple parameters, there are methods which return values, there are methods which throw some errors, and so on. Also, at the moment I've already created some mock for this dependency. As you can see, it is a really dummy object. It doesn't do anything and only returns some default values when it is needed by the API. There are some tests already implemented, so as you can see, each test executes its own API call on the system under test, but no tests check anything, so the tests pass by default, which is actually awesome because it means that at least the project compiles. So let's start with some most basic mock to do. And what if your dependency has some method without any parameters? Usually in this case, developers are interested in how many times this method is executed during a unit test. So let's implement this functionality in our mock. I prefer to create the structure per each method in our mock, so it could store all the data about some particular method and how many times it was called. So let's create the do something mock structure, and it's going to have only one internal property named calls count. It's going to be integer, and by default it's going to be 0. Now let's create a variable of this structure in this mock, and whenever the do something method is executed, now I could address the calls count inside the do something mock and increase this property by 1. Now in the test, when, for example, simple call is executed on the system under test, I could check that the dependency which is used in this system under test executes the do something exactly one time. Actually, let's check if it is 2. For sure, in this case, the test should fail. Yeah. That's because in actual system under test, the dependency do something is executed only once during the simple call. Alright, so this was the most simple one. Now, what if your dependency has some method with a parameter? In this case, probably we would like to know what exact parameter was provided with some exact call. So let's implement this functionality in our dependency mock. I'm going to create another structure. Let's name it do something with parameter mock, and it's going to have an internal property, something like parameters history. Basically, it is the history of calls. Let's create the do something parameter mock instance as a property in this mock, and whenever the do something is executed with a parameter, I could actually append the parameter to the history inside this mock, right? And also I don't need the calls count anymore in this mock. Actually, I could replace it with some computable property, which is going to return the count of the parameters history, basically the amount of times we've appended something to this array. Now let's get back to the tests, and now actually we could check first the exact number of calls of do something with parameter, but also we could check the exact parameter itself which was used at this call. So we are going to check for the last, and we are going to check that it is, for example, an empty string, which sure is going to fail. So yeah, it fails because during the execution the system on the test actually uses a string as a parameter on this call. So let's replace it, and the test is going to start passing. All right, let's increase the complexity a little bit. What if we have some method with a parameter which also returns some value? How we could configure the mock to return some particular value from the call? So let's get back to our dependency mock, and let's copy paste our previous solution to be used in our next method. So I'm going to name it something like do something with return over here. So we are also going to return to create another instance of this structure. And this time we also are going to create additional property, something like a returning value. So in this case, the returning value should be a Boolean type, right? And there are two options here. I could either provide the default value for the returning, or I could make it optional. I prefer to do it as an optional, and I will explain it later. So now when the do something is executed and it should return some value, then first again I'm going to append the string to the list of the parameters history, and next I'm going to return the value which is contained in this property, and I'm going to force unwrap it, which means that if this property is not configured before the test, then it's going to crash. And actually it is a good thing, and let me explain you why. So over here we could again check for execution, but this time we are going to check the do something with return mock. Also we could check what exactly is used in the system on the test, so it's the str string. So, and this test is actually going to fail because yes, we did not specify the returning value for this particular method. The thing is that, well, if you would provide some default value for every mock, it could easily mask misconfiguration and create much more problems. But to be honest, it's completely up to you if you would like to use the default values in your mocks. So I'm going to configure the returning value over here as the true. Now let's call this test again, and it started to pass. All right. So what about the properties? Basically, properties could be either gettable or gettable and settable. And if you think about it, the gettable property is just a regular method with the returning value and 0 parameters. The setter is the opposite. it doesn't have any returning value, but it has one single parameter. So let's modify our dependency mock. So we are going to create two structures this time. This is going to be the some property getter get mock, and it's going to be the some property set mock. So the get mock is going to have the returning value. It's going to be integer in this case. Also, well, it doesn't have any parameters, so let's create the parameters history of voids. For the sum property set mock, we don't need any returning value, and the parameters history is going to be used to log all the values which were set with this setter. So the type is going to be the array of integers. Now let's create two mocks over here. So the sum property get mock and sum property set mock. All right, and now let's use them in the property itself. So here we are going to use the returning value, and here we are going to just append the parameter history with the new value. And by the way, we should also do it over here, but we are going to append void. All right, now let's go to the test. We have two tests over here for read and write operations. So whenever something is read from the property, we could check, for example, how many times it was read. So it's going to be some property get mock, and we expect that the calls count is going to be 1. But again, we should specify the return value for this case, and it's going to be, for example, 7. Yep. And for the property write operation, we could also check that, for example, it was implemented, it was called at least once, and we could also check what exact value was provided with this call. So in this case, we do expect, 1 second, let's check that, property rate 67. Actually, let's check both tests and provide some different values, just to be sure that this test fail when comparing the values. Yeah, so the calls count should be 1, and here we are going to use 67. Nice. All right, so these were the properties. And what if you have some dependency with a method with multiple parameters? How we could implement that? All right, for that, let's go to the mock, and we are going to just copy paste our previous solution over here to be used for our next method. So yeah, here we have multiple parameters. So let's rename it to something like do something with multi-parameters. We are going to create another instance over here. And in this case, our parameters history should not log only the string, the first parameter, but actually it needs to log a couple of values. So I suggest to just use tuples over here. So these are going to be the tuples of strings and integers. So whenever they do something with multiple parameters is executed, then again we are going to append our parameters to the history using the provided string and number. And again, we are going to use the returning value of this mock as the returning value of the method. Cool. So now let's get back to the tests, find the test for this particular functionality. So our system under test has the multi-parameterized call. So let's first set up the returning value for this mock. So it's going to be, let's say, true this time. And after that, we again would like to check the calls count first for the do something with multiple parameters, that it was executed only once. And as for the parameters history, now we are able to check two parameters, the string and the provided number. So let's check that first it fails with some random values. Yep. And if you would go to this system and test, you would see that it uses another string and number 42 when it is executing the multi-parameterized call. So let's use them over here, and the test should start passing. Nice. Okay. We are continuing to increase the complexity of the method which is executed by our system under test. And what if our method also can throw an error? How can we handle this one? All right, let's get back to our mock. Let's again copy paste our previous solution to be used in the next method. So here I'm going to name it something like do something with throwing. All right, and let's have an instance of do something with throwing mock over here. So in this case, the method could finish with like two results. Like it could be either a returning value or it could throw an error. So let's replace the returning value with the result type. Yep. So the result value is going to be a Boolean type, and the error is going to be a sum error. If you don't know, the result is the foundation generic enumeration, which has only two cases, success and failure, with two associated values. The success associated value could be of any type, and failure must be an error. All right, so now we could again just copy paste our previous implementation over here, just replace the mock to be used, and over here we are going to switch the returning value. So in case of success, there is some value which this mock should return, and it's going to be returned like this. In case of error, we would have an error provided in this case, and we could just throw this error. All right. And of course we could force unwrap it. Now let's go back to the tests over here, and actually let's try to mock the failure. So we are going to use the dependency, do something with throwing mock. Returning value is going to be a failure with some error, or should it be some other type? Let's check. So we have this error specified over here, so we could use the typical error. Okay, and after that we could again check for other stuff, like the amount of calls on this mock, the parameters. So let's execute this test to check if it's going to fail with these values. Yep, that's because the actual call of the system and the test using this string. So we could check the values like this, and the number is 23. And now the test should pass. All right. So now the most juicy part. What if our method is also asynchronous? Like, what could we do? First, let's check what it would happen if we would just copy paste the solution from the previous method to be used in exactly the same way for the async. So I'm going to name it something like do something with async mock. So we are going to have another property of this type over here, and yeah, we are going to just copy paste this implementation here. The only thing we are going to check is the mock which is used here. Cool. Now let's do the same in the tests. So we are going to specify the returning value as a throwing error for the do something with async mock, and also we are going to check for the returning values and the amount of calls on this mock. And this test is going to fail, but not because of the values mismatch. Actually, it fails because of all mismatches. Let's check for the values first. So instead of this string, we are going to have this string, and instead of 23, we are going to have 22 to 8. But still, it's going to fail because the it was never executed synchronously. Yeah, as you can see, it was executed 0 times. That's because basically when system and the test executes it, it creates a task which finish immediately, and this code probably is not even executed. So how we are going to fix it? I see that we do need some new Swift concurrency based instrument to help us wait for some exact number of calls of some particular methods, no matter which actor or task executor they use. So let's implement this in our dependency mock. I would call this instance a new actor await mock. And as it's going to help us to wait for something, it's going to contain the internal collection of continuations. So how we are going to store them? As we are going to wait for some particular amount of calls, there could be multiple continuations waiting for different amount of calls. So let's store the collections of continuations by integer, the number of calls. And each collection is also going to be a dictionary, a subdictionary, because each continuation is going to be identifiable. So it's going to be the checked continuations. They are not going to return any value, but they could fail. All right. So this is the collection of continuations. Now let's create a method, something like await, and here we are going to get the calls count for the new continuation. And of course, it's going to be async and throwable method. So let's try to await with check throwing continuation, and whenever we are executing this, first thing we should do, we should extract the count continuations basically the continuations for this exact calls count for our current from our current continuations collection. So if there is nothing, then we are going to just return the empty dictionary. Now we are able to first generate the new identifier using the UUID, and we could put our continuation using this identifier to this subdictionary. And finally, we should store this new subdictionary in the continuations using the calls count. All right. Now let's think that, well, the await could fail basically because of the timeout. So in this case, let's first create a special error for that. Let's name it something like await error of error type, and it could have only one case. Let's name it something like timeout. So when we just created the continuation and stored them in our continuations collection, now let's create a task, and in this task we are going to, well, await for some time, giving some time for the continuation to be resumed. So we're going to sleep. Let's not use the nanoseconds. Instead, let's use something like milliseconds. For example, for 100 milliseconds. After that, let's check that our continuation still exists in the collection. So we are going to check for the count continuations in our continuation for this particular calls count. And if it exists, we also are going to check for the continuation itself using the identifier. So it's going to be the calls continuations for the identifier. Nice. If it is not there, then, well, probably it was already resumed. We are going to deal with that later, but in this case we are not going to do anything. But if it exists, still exists in our collection, then, well, first of all, let's modify the count continuations. For this exact identifier, we are going to nullify remove the continuation. Then we are going to set the new value for the inside the main dictionary, right? And now we are going to resume our continuation with throwing the error. Let's use the await error timeout, which we have just created. All right, so this was the negative scenario. Now let's create some API to resume the continuation properly. So let's name it resume, and again, well, it's going to consume the calls count over here. So let's check our continuations for this calls count, and for each continuation over here, so we don't care about the identifier, we're checking only for continuation, we are going to just resume it, right? Now we are able to use this await mock in our structure, which is do something mock asynchronous, right? So let's create an instance first of this await mock. Right, and now let's create two methods here. The first method is the method to await for the particular amount of calls. So let's just copy paste this line over there. All right. So over here, we actually could check if our calls count is less, calls count is less than the provided calls count, because otherwise this calls count already was reached and we could just return from this method. If no, then we are going to use our await mock and we are going to await for this calls count. All right. And of course it is the async method, so we need to use await here. Another method which we are going to use inside this method itself is the resume with no parameters. It's also going to be async, and basically here we are going to await for the await mock resume with our current calls count. Now, how we are going to use it? So basically, whenever the method do something async is executed, first we are going to store the parameters, and then we are going to use the do something with async mock resume, which is going to resume all the continuations which are awaiting for our current amount of calls count. Now let's go back to the test, and instead of just checking the calls count for dependencies, let's actually wait for this number of calls count. So we are going to await, for example, for one continuation. In this case, the test is going to start passing. Oh, it's not, because I didn't provided the await again. And of course, it is a throwable method, so it's going to I'm going to try to fail it. Yep. So now it is done. Yeah. Actually, we could check and wait for example, for 2 calls. In this case, the test is going to fail after 100 milliseconds. Yeah, and this is how it works. All right, and this is all for today. Basically, these are all the magic templates which are used in my work, and you could easily reuse them in your projects. Actually, all this mock generation even could be automated, because as you can see, the way from the API of the protocol to the actual mock implementation is very deterministic. You don't even need AI for that. And if you would like to see me doing this, or if you have any other questions, then feel free to put those requests and questions to the comment sections. Also, please find the link to this exact repo in the description of the video below. And see you next time. Cheers!